Let's talk about the meaning of linear equations in two unknowns. First thing we're going to do is start with the equation 2x plus 3 equals 5. Now this equation is called a linear equation in one unknown, x, just because we have that one unknown, and then if we were looking to solve, I would subtract 3 from both sides, which would get me 2x equals 2, then I divide both sides by 2, and I get x equals 1. There's my one unknown, x. So this equation has a unique solution of x equals 1. But what if I were to change it up a little bit, and instead of having 2x plus 3, I had 2x plus y equals 5? Well, this equation, 2x plus y equals 5, is a linear equation in two unknowns. This time I have x and y. So what I have to think about is, how many solutions are there for this equation? Well, if y equals 1, then I would have 2x plus 1 equals 5. Subtract 1, subtract 1. 2x equals 4, so x equals 2. However, I could also say y equals 2. If y equals 2, then I have 2x plus 2 equals 5, 2x equals 3, and x equals 1.5. Well, I could also say, well, what if y equals 3? Then I get 2x plus 3 equals 5, so on and so forth. So what we can see is that there are many different solutions to a linear equation in two unknowns. There's more than one, and there's a reason for that. Because what we can do with 2x plus y equals 5 is graph it. And let's see, let's move it over here. Clear out some space. I can take a graph of what 2x plus y equals 5 looks like, and it would look something like 1, 2, 3, 4, 5. Bloop, bloop, bloop. We go 1, 2, 3. My line would look something like this. That means at any point, any point on this line is a solution for the equation 2x plus y equals 5. So as we can see, we have many solutions. Let's take a look at a table here. You can go ahead and complete this table, copy and complete this table on your own, or you can go ahead and watch me. But what I'm going to do is check these different values, these different points, to see if they're a solution of the line 2x plus 3y equals 18. So first I have some points over here. Then I'm going to see the value of 2x plus 3y. So 2 times 0 plus 3 times 6. 2 times 0 is 0 plus 3 times 6, which is 18. Whoa, hold on there. So I get 0 plus 18, which is 18. Then is the ordered pair a solution? Yes, it is. If I take the next one, 1, 5 and 2/3, so I have 2 times 1 plus 5 and 2/3 times 3, 5 and 2/3, 5 times 3 is 15, 16, 17. So I have 17/3 for my y times 3 over 1. 3's cancel and I'm left with 17. So I have 2 plus 17 is 19. So the answer here is no, it's not the ordered pair is not a solution. Alright, let me try 2 and 5. So I have 2 times 2. Let's try that over here. 2 times 2 is 4 plus 3 times 5. 15 plus 4 is 19, not 18. How about 3 and 4? 3 times 2 plus 3 times 4. 3 times 2 is 6. 3 plus 4 is 12. 6 plus 12 does equal 18. So 0.34 is also a solution of 2x plus 3y. And then I'm going to take a look at my last example. 4 times 2 plus 3 1/3, which is 10/3, times 3. So 8 plus 10 is 18. So yes, we could see that 0, 6, 3, 4, and 4, 3 1/3, those ordered pairs are solutions of 2x plus 3y equals 18. So what we can see is that we can plug values into an equation to see if they're part of a solution. What we can also see is that we can graph the line of the solution, the line of the equation, and then that'll show us the solutions, all of these points. And if you've forgotten how to graph the line, we'll talk about that later, or not. We can make a table to see if the values fit. And then finally, we can put that all together in today's challenge, which is a word problem. Particle A travels at x meters per second for 3 seconds. Particle B travels at y meters per second for 4 seconds. The distance traveled by A is 12 meters longer than that of B. So first thing you want to do is form an equation connecting x and y. Then draw the graph of the equation for 0 is less than or equal to x is less than or equal to 8. So your graph will focus just on the points, the positive value coordinates of x and y. And then find out if h, 5 is a solution of the equation, find the value for h. So my hint here will be to plug that in for x. You're going to be solving for x. All right, good luck with this problem.